Officially welcome everybody to 50 Ways to Accelerate Your IoT Project. Over the next hour or so, we're going to dive into what we call the Blues accelerators. These are 50 plus purpose-built IoT applications that are all free. They're all open source. Technically, they are ready to be deployed today, but more likely you're going to clone them, hack them to correspond to your own application needs. As I just mentioned, before we really get started, those of you with a keen eye may have seen the new Blues logo in the corner there. Yes, we are going through a rebranding exercise. It is the same old Blues you know, of course, but you'll start to see the rollout of some new logos, new fonts, new colors. Most importantly, we're dropping wireless from our name. So now it's just Blues going forward. Now, as questions come up during the webinar, whether it's specific to the demos we're showing or more general in nature, feel free at any time to use the Q&A panel provided in your Zoom viewer. We will actively answer as many of the questions as we can privately, and then at the end, we will publicly answer some of the best ones as well. So since we have 5 people who are not going to be demoing at any given time, we should be able to handle any questions that you have. Speaking of questions, we always get the question, is this being recorded? And the answer is yes, it is being recorded and will be available on our YouTube channel. That is now off-brand at this URL. While you're there, of course, I recommend subscribing to the channel so you're the first to see any and all new video content. So let's do intros. We've got a bunch of people here today, starting with myself, the least important person. My name is Rob Lauer. I'm Director of Developer Relations here at Blues. Along with me today are the people doing the big demos. Zach Fields is first. Zach is our staff DevX engineer. TJ Van Tol is our principal developer advocate. Paige Niederinghaus is our staff software engineer. Hayden Roche is a senior software engineer. And last but not least is Tyler Wojo, because I already forgot how to pronounce his last name, who is a senior field application engineer here at Blues. So thanks in advance to everybody here, and may the demo gods be in our favor today. Now for the agenda, very straightforward today. It's a no fluff, demo-filled day. We are devoting the entire time to demos of some of our best or our favorite accelerator applications. Again, if you just joined, these accelerator applications are free. They're completely free, completely open source. The firmware for each, and there's firmware written in anything from Zephyr, Arduino, C. There's even some CircuitPython applications as well. So the firmware that's provided demonstrates some really great best practices with using Notecard and Notehub. Some even have a pre-built cloud backend as well that you can clone and mess with as you see fit. And you can find all the accelerators on our developer site at blues.dev/accelerators. And yes, there are 50 plus accelerators. You might even hear us call these Nifty 50, either accelerators or Nifty 50. It's the exact same thing. They both mean the same. Nifty 50 because obviously there are 50-ish applications. Each listing on the site does come with a short description and links to the source code on GitHub. Some also have a really nice comprehensive tutorial written up on Hackster. And for example, we have pre-built applications that span from an indoor floor level monitor, which includes not only the firmware, but also a complete cloud backend. TJ is going to show this one off today, I believe. We also have much lighter applications, like the one I'm going to show off, that doesn't even need a host microcontroller. You don't write any firmware for it. It just uses the Notecard and Notehub without a host. Now, I've thrown a bunch of terms that some of you may not be familiar with yet, so let's take one step back. I'm sure some of you are new to Blues and don't even know what the Notecard or Notehub are. So here's your 1-minute overview. What you see here is the Notecard. It is a cellular IoT device. It does come prepaid with 500 megabytes of data and 10 years of global service, all baked into the cost of the device. There's no subscription fees. There's no monthly SIM fee, but it is only half the story. The other half is our cloud service that we call Notehub. Now, the two work together to form what we call a device-to-cloud data pump. Now, in practice, what this means is developers are going to buy like a starter kit from us. You're going to hook up a sensor to it, start reading data from that sensor with the host microcontroller, and then, of course, deliver that data securely over cellular to Notehub. But we don't want your data to live on Notehub. We're not here to create a platform, if you will. We exist to help you connect to your platform, be it a big cloud like AWS or Azure, or even an IoT platform like a DataCake or an UbiDots. We're really trying to help solve this messy middle piece of connectivity, if you will, so you all can easily and securely connect your devices to your cloud applications. Now, if you're new to Blues, I recommend checking out our main website at blues.io for more product information. With that, let's jump into the demos. So there are 6 of us presenting. So we have 6 accelerator demos to show off. And I'm going to start by showing off what's probably the simplest of all the demos today, and that is a power outage monitor. So imagine any scenario where you want to be alerted via SMS if power is cut, right? So maybe you are monitoring a cold storage device. Maybe you want to monitor power outages in your cabin that's 500 miles away. In any case, I'm going to show off how simple this is to set up with just a Notecard, Notehub, and then Twilio for the SMS alerts. So first, I need to send 2 requests to my Notecard, only 2 and just one time, to configure it to work in this scenario. Now, again, if you're new to the Notecard and Notehub, everything is JSON in and JSON out. That's all the APIs are completely based on JSON. So the first request I'm going to send is a hub.set request. This simply associates my Notecard with my Notehub project that I'll show you in a bit. For the purposes of this demo, my Notecard is in continuous mode, which maintains a continuous cellular connection. Literally, the only other command I sent to my Notecard is the card.voltage request. This particular request tells the Notecard with the USB true parameter to monitor changes in the USB power state, and then with the alert true to add an alert to the health.qo note or an event that you'll see in Notehub, and then finally to immediately sync the data with Notehub when it happens with that sync true parameter. And of course, all of these are fully configurable to match your individual app needs. So let's first see it in action, because it's a very, very quick demo. And if you blink, you'll miss it. So I am going to spotlight myself. I think I can do that. I'm big now. Okay, hello, everybody.
So I'm going to cut power to my house.
Yes, exactly. So hit the breaker. So I'm going to start by showing off the hardware here really quickly. Again, super simple. If I can focus here. Oh, my camera does not want to focus on what's in front of it. Okay, good enough. So here's my Notecard, obviously. I've got it on a Note Carrier A carrier board. The A is really nice because it's nice and compact with onboard antennas. I've got a backup power with my LiPo battery here, which is actively charged and maintained via this JST connector here. And it's powered via this micro USB cable. Pretty straightforward, right? So all I'm going to do is literally cut power. So it's like I'm doing a magic show or something here. So power's been cut. What I should see is, this would be hilarious if it doesn't work, because it's worked about 8 million times until now. And we're going to see that
well, it is supposed to take a few seconds because it has to send a cellular signal from Rob's basement and then send the SMS. So
so I'm gonna switch over to show Notehub to prove that this actually works. And here we go. It's working. So let's head over to Notehub here. Let's share my screen again. And so I'm going to start here. While I'd love to do a full deep dive into Notehub, obviously I just want to show what's specific to this application. So first is my device screen. This is literally the device that's connected to my Notehub project right now, and that's all. The other thing I want to see is the events. So these are all the notes that have been sent back and forth from Notecard to Notehub. And you can see that, let's look at this top event here, this health.qo note file with the USB power off. So this was just sent. The fact that it didn't happen immediately freaked me out, but here it is. Just to look at the details here a little bit, we can see that there's a lot of metadata associated with this note, like some timestamps and some locations. What we care about is this USB power off text in the body element. Now, again, we don't want your data to live on Notehub. It doesn't make sense for this alert just to go to Notehub. We want to trigger a Twilio endpoint. To do that, we have a feature in Notehub that's called routing. And I've set up a Twilio SMS route. And let me show you that really quickly. Very easy to configure. You assign some of your Twilio account specific information at the top here. Just ignore anything that's supposed to be private. And down at the bottom here, I gotta move my Zoom viewer here. We can see that I'm only triggering this Twilio route based on those health.qo note files. That's important to do as well. I don't want to trigger it based on any thing that gets sent willy-nilly. But most importantly, the coolest feature of routing is this ability to use JSONATA expressions. If you're not familiar with JSONATA, it's a super powerful language, a little bit like regular expressions in terms of being able to modify JSON on the fly. So what's basic, I'm not going to go through this in detail. What basically is happening here is it's saying, hey, if there's a USB power off or USB power on detected in the note, send this message on to Twilio. And in fact, just to prove I'm not lying, I did get this text through. If I can show it on my screen here, it says, I'll read it off to you. Alert powers failed to device, and it gives me the device ID. So it does actually work. And in fact, I'm going to plug my note carrier back in really quickly because I'll get another text message that will say that the power was restored, which I did just get. And so it came in immediately. You have to trust me if you can't read it. So that's it. That's my extremely fast demo. I'm going to turn it over to Paige, I believe, is our next presenter.
That's right. Thanks, Rob.
And I can't find my Zoom controls. So if you want to just take over the.
Sure, I can start sharing my screen. Yeah. Oh, I cannot while you are sharing.
There it is. Found it.
There we go. Cool. Hey, everybody. So as Rob already said, I am Paige Niedringhouse. I am a staff software engineer here at Blues, and I am going to be demoing for you a cellular connected electronic kiosk. So imagine, if you will, you see these kind of things maybe at shopping malls, in office buildings, in warehouses and manufacturing facilities. They're basically kiosks or, displays that are helping to show people what the traffic is when they're leaving the office, or what the weather is, so they know if they need to take an umbrella, or just basic information about the stores and the shops that are around them. So typically when you're building one of these types of things, it needs an internet connection. And a lot of times manufacturing facilities, for whatever reason, they don't want to put this type of thing on their Wi-Fi. Or if you're, like I said, in an outdoor area, you might not have Wi-Fi or internet to be able to send data and update these kiosks as conditions change. So what we wanted to do was build a cellular-enabled kiosk, and we're doing so with a Raspberry Pi, a note card, and a note carrier Pi hat. So this is actually the GitHub code that shows it off that I'm sharing right now on my screen. And I'll scroll down and show you a little bit of the hardware. It is really just a standard Raspberry Pi, which you can see right here. We've got a note carrier Pi hat on top of it, and a note card, which is stacked right in the middle. So all of this has been put into a 7-inch Raspberry Pi display, which I have my own right here. So that's what it looks like as the end result. And this is our kiosk. So the easiest way to understand how this works is you will download a very small repo to your Raspberry Pi. It's one Python script and a little bit of, basically that's it. It's really just a couple of Python scripts. You will have your web application, or whatever it is that you need your kiosks to display, zipped up into a zip file and stored in a publicly accessible cloud. So for us, I built a very simple weather web application to kind of demonstrate it, and I put it into an Amazon AWS or an Amazon S3 bucket. So it's there, it's available for download, and through the magic of Notehub, I am able to set environment variables that tell my project to go find the kiosk zip file, which is my web app. I'm allowed to set a content version, which is how, after the file starts running on the Raspberry Pi, it knows when to actually update. So if you have a new content version that you need to push out, like you've made some updates, you've re-uploaded your web app, you have something that needs to be downloaded again, by changing this version, that's how the Python script will know that it needs to download whatever the new data is. We have some kiosk data, which I will share in more detail when we actually go through the video that I show you demoing how this works. For now, just know that it is a list of cities. So I have New York, Paris, London, and Rome in here. And then we have this kiosk download time. And this is a really interesting environment variable because you can either set it to now, which is what I did, which says that whenever either the kiosk content variable or the kiosk content version update, whenever they change, the Python script should download the new information immediately. Or you can have it set to a particular time, like say 3 a.m. when nobody is at the shopping mall or no one is at the manufacturing facility, because it does take a little bit of time for the Raspberry Pi to download the web application, depending on how large it is. So if you don't want it to happen during regular business hours, you can set it to some off time. And then every day at that particular time, it will check if there are changes and then it will download the new information. So let me show you a video which will help to demonstrate. So like I said, this is actually my Raspberry Pi sitting on my desk, and we have a Python script which I've downloaded locally, and in here we're setting the directory where the data should be downloaded to on the local Raspberry Pi. We have the name of my Notehub project. And then we have the route, which is actually the name of the zip file that my kiosk is going to download. So if you had an Amazon S3 bucket that had more than one zip file, maybe you had one that was for weather, maybe you had one that was for stocks, maybe you had, what have you. If you had multiple versions, you can specify it should download this version or another one, just depending on the name. So if we start the video up, I give you a quick version of that. And if we back it up just for 1 second, back it up, we can see that it is really quickly configuring and uploading or configuring and downloading the web application. And you can see it just scrolls through. It shows the weather for these different cities. Now, let's say that you actually wanted to change the cities that were being displayed with this web app. You might think that you would have to change the code, upload it back to Amazon, and then download it again. Well, not quite so. For really small changes like this, I'm not saying you could, change a whole web application with it, but for small changes, you can actually use the Notehub environment variables again. So as you saw, we had Mexico City, we had Munich, we had a couple of other cities. Now we want to change that. So I'm actually going to go to my Notehub project using this Raspberry Pi just to show it all on one screen. And I'm going to change this kiosk.data environment variable, which we saw before. So as you can see, it has a list of cities, Los Angeles, Tokyo, Munich, and so on. And we're actually going to change that. And now it's going to be the New York, Paris, London, and Rome that you saw before. So I save that fleet environment variable. I come back over to my Raspberry Pi kiosk, and you see the Raspberry Pi Python script is actually registering these new cities. It's realizing now that New York, Paris, London, and Rome are the cities that it needs to display the weather for. So it realizes that has happened, it registers it. And if we go back over and look at our connected kiosk, and I'll blow it back up to full screen, we will see that in just a few seconds, this change is actually going to take effect in the browser, and we'll no longer see the old cities of Munich and Tokyo. We will suddenly start to see the new cities, which is going to happen any minute now. And there we go. So now we have Rome, we have New York, we have London, we have Paris. So without even having to change the zip file and the web app itself, you're actually able to do some slight modifications without having to deal with uploads and downloads, which is pretty sweet. And I also should mention that for this particular application, the Notehub environment variables that we're using are all fleet specific. So if you had a bunch of kiosks, either in a shopping mall, in an outdoor plaza somewhere, in an office or a warehouse, you could have all of these devices syncing, and you change the kiosk data for one, you change it for them all, which is pretty sweet. So you can manage multiples without having to think too much about it. So yeah, it uses a note carrier Pi, a Raspberry Pi, and a little bit of Notehub routes and environment variables. And there you have it, a kiosk that doesn't need to be connected to the Wi-Fi because it has its own cellular internet connection.
Awesome. Thanks, Paige. Zach, do you want to jump in now and do your?
Yeah, if you can hear me right now, I'm good to go. All right, great. So, all right. So if you guys just enjoyed Paige's articulate, well thought out and polished demo, then you'll hate mine. So here we go. I'm gonna go through, and the one that I'm going to show you today, let me jump over and start sharing my screen here. Not that one, but here we go. I'm going to jump to our accelerators page. This is where most of these apps live and are coming from. That's what we're talking about today. The one that I'm going to be showing is the valve monitor. So that's this guy right here. If we look at it, it kind of lists out the key features. Similar to what Paige was talking about, we have environment variables, we have fleet management, we use an RTOS. That's not really described on the key features here. And let's see, what else can I see looking right at it?
Just so you know, Zach, we can't see anything because the resolution is so horrible.
Oh, it's so bad? Okay, great. That's just what I'd like. So,
but everyone should just know this exists.
I would encourage everyone to go to dev.blues.io/accelerators and look at this for yourself so you can read it. So
I'm going to drop some links in the chat too. So
yeah, I won't rely on the text. But anyway, it's hosted right here. So if we don't have resolution, then what I'll try to show at a high level then is, let's see, what would all these things require resolution? Yeah. Can you see this web app okay? Is this big enough to visualize anything?
It's a little blurry. You can kind of make it out though. I think you're good.
I'm going to take that as a overwhelming, awesome signal. So, all right. So building on that, I'm going to jump right over to the sync. So I'm demonstrating a sync that uses the valve monitoring. So it's an easy demo. This is also going to look really Blair Witch. I don't know, I should be standing down here and waving, but this is going to look really Blair Witch because I need to move this camera around to kind of show you what the guts look like. So here we have a note card, note carrier F. We have a solenoid, a flow control meter, and some relays and whatnot, as well as a pump that's going to drive the water motion. And then let's see, what else would I show? And then a sink, which is my valve, and then a pool of water, so I have water. All right, so let's see. Yeah, like I said, super Blair Witch, apologize for that. Anyway, so let's see how we go. Yeah, so let's turn it on, fire it up. So what it's going to do when it starts up is the sync's going to start running. Here we go. And now what I'm going to want to do is go over to the web app, and this is going to use all the same things. I'm talking over running water, which is awesome. This is going to use all the same things, environment variables, everything that Paige just discussed. So it's really nice that she was able to set that up for me. But we've also released a canned web app. So this web app that you're looking at is something that's open source that we're actually offering. So here I'm going to click the valve button to close the valve. You should hear this sound stop soon. I love this. All right, so it's down. I can see that it's the note card's flashing, so it's either trying to make a connection to the tower here from my office and not doing a good job, or it's downloading the new request to turn it off. This worked perfectly just a handful of seconds ago. I am getting, there we go, finally. Okay, great. So that took a minute, but that's because let's just say it's because I just turned it on. I actually think that's what it is, in fact. So I just turned it on. It had to connect to the tower. I'm using a narrowband global. So this is a note card that can kind of travel around the world, but it uses narrowband IoT instead of wideband IoT. That offers an enormous amount of benefit. However, the one drawback is that it is a little bit harder for it to establish a connection because of its ability to talk to so many things, but then also only in the narrowband spectrum. And then that's impressive actually here because I live in the Ozarks, which you wouldn't really expect a narrowband. So really it is very global and it's accessible anywhere. But so to also explain, I use the same trick as what Rob was using with Twilio, and you can see, well, my watch is also a phone, I should mention. And so I'm not just showing you my watch, but I've got alerts. I don't know if I can show this or not, but let's try. Right there. Yeah, this is horrible. But anyway, right there, it says that I've got an alarm, which you couldn't read the numbers on the web app because it's blurry, that it's over its threshold of flow rate. I could adjust all that by adjusting the handle on the sync itself. Let me flip back over and see. So then if I wanted less flow, let me turn it, I'll re-enable it with the web app. So I'm trying to flash all over the place. But I'll make sure you're all dizzy and sick before this is over with. All right, so I'll try to re-enable it here. Hopefully this will go a little faster. Yeah, much faster, because now I've got my connection established. So, all right, and then let's flip back to the sync running. If I were to do this, then I won't get a text message now because I've throttled the valve, so it's not giving me any alarms. If I open it back up wide, I start getting text messages again. But anyway, all of this is available, open source. Be happy to discuss it in the Q&A. And let's see, I need to kill this thing. Yeah. Anyway, I'll be happy to discuss it in the Q&A. I know I glossed over that super fast. It really was dependent a lot on my video working well, which it is not. So I apologize for that. I'd love to also talk about the Zephyr stuff that we've done and how we set up a full environment for that. That's something that is also accessible through our GitHub, which is linked on the Nifty 50 pages. So really, I can't encourage you enough to go to blues.dev/accelerators and check out the content on the Valve Monitor, because that is an amazing setup where you get a web app built for you. So it's using Notehub as a web application. You can just start there with your product. Also, it has full instructions for how to build this exact demo. Well, less the sync part, I had to go buy that. But otherwise, if you have any questions, put in the Q&A. I'll start answering those, and I'm going to turn it back over and let someone else do a good job of presenting. And I'll catch up with you guys in the comments. Thanks a bunch.
Thanks, Zach. If you can't tell, we're all extremely nervous about our demos working well. And this
I like how everybody freaks out. It is a cellular connection, people. Like, I think both you and Zach freaked out after like 5 seconds.
I know.
Like, it does have to talk to a cellular tower and come back down. Like, it's...
It usually goes so fast, though. That's why it's just it's not instantaneous.
All right, TJ, do you want to go next?
Sure. Yeah. So I'm going to be talking about the indoor floor level tracker, which I'm bringing up right now. And conveniently, Rob, like right now, is putting a link to this accelerator in the chat too, which is super, super useful. The indoor floor level tracker. It's also one of our accelerators, blues.dev/accelerators. And what I like about this one is that it's got a really simple hardware setup. In fact, and I'll hold up mine, or you can just look at the picture on my screen. It's basically what you get in a standard Blues starter kit. So a note carrier F, a Swan, and a note card. So just, and the antenna, so straight out of the box, with one additional sensor, the BMP 581. And the 581 is a barometric pressure sensor. So the idea behind this project being an indoor floor level tracker is that by measuring the barometric pressure and its changes, you can approximate the floor someone is at within a building. The really intended use case for this is for emergency responders. So you can picture this device. I plug a battery into this. I toss it in a little plastic case. I toss it on my belt. I have a whole bunch of these. My whole team's got them on their belts. And we take off into some emergency building, emergency situation. And then somebody on the ground can sort of monitor where we're at. If we're going up and down, maybe if we've stopped moving, Maybe there's some other sensors we might want to hook up to this so we can just establish a mission control of people heading into an emergency situation. So in addition to this hardware, which again is pretty simple, it's basically just plug a sensor into the standard Blues starter kit. We also offer firmware and a web application for this one as well. So the firmware for this one is an Arduino app, which I've already got downloaded and running on the device on my desk. I've also got the serial monitor open because we're going to look at that here in a minute. Right now, it's just looking for environment variable updates. And the only change I've actually made to this is I just downloaded this straight from GitHub. I put in my own Notehub product identifiers so the Notecard knows to where to send its data. But other than that, this is just the stock firmware I got from GitHub. This project also has a web app that's sort of a reference implementation that you can check out. This one, it has two sort of unique sections. The first is just listing all the devices in your fleet on Notehub. So you can see the device on my desk sitting right here is active. So I'm getting live data from this. And this fleet also has some devices as we were testing this out when we first built this project here as well. But you can picture the situation is that, again, we've pulled up to a burning building. Me, Brandon, Paige are getting out, and this is starting to track our data and sending it to this sort of mission control dashboard. In addition to this, we also allow users to control fleet variables. So these are environment variables under the hood. I think one theme you're going to see throughout our presentations is that Notehub environment variables are pretty awesome and just make a lot of cool things possible. So in this case, these are fleet level environment variables. And this one, this very basic one for live tracking, basically just turns all the devices on. So by default, the firmware here has two different modes. By default, it's kind of in a battery conscious mode where it's just sort of casually tracking the device. But considering this is for emergency events, we can put it into live mode where we don't care as much about the battery because we want to be getting really active data. We want to know exactly where these devices are at all times. And environment variables make this kind of handy because by just flipping this one switch, I can activate this tracking throughout my entire fleet. So if all of us had devices on and we were heading into a building, instantaneously, those devices know, hey, it's go time. I need to get data. I need to start sending it to Notehub immediately. The other thing, alarms and alerting is another common theme of these projects because it's a common IoT use case. So in this case, the alarm would be if someone has stopped moving, because that's usually bad in something like a burning building type of situation, and you want to know that immediately. So we have an environment variable that you can configure for how long, if someone doesn't move, should it send an alarm. And I had it sent to the lowest value because this is a demo. And since this thing is statically sitting on my desk and not moving, I immediately got alerted that there's some sort of problem, which in this web app, we're mapping to just showing a red row. But we could use an approach like Rob showed earlier, or like Zach showed with his watch, to send out like an SMS or whatever sort of alert or warning system of your choice. So that's the alarms. I'm going to clear this off as well. There's some additional functionality for when the floor changes. Unfortunately, I don't have like a large scaffolding outside my house to climb up real quick to show that, but I can kind of approximate it, kind of sort of, because we allow you to also configure the floor height, because under the hood, the firmware is basically doing a bunch of math on your behalf. It's saying what is the baseline barometric pressure, and as that changes, it does some math based off of common floor height that you can configure to approximate what floor of a building the person is on. But we can have fun for a demo and just say floors are really, really tiny so that I can change them just by raising the device. And so after I changed that, I saw in my serial monitor that my device got that changed right away. So when I raise my device up and I come back here, you can see that, man, I just went up to floor 10. And probably if I drop it in a few seconds, I could get it to change back as well. But what I like about this app is like this is cool, even if you're not building an indoor floor level tracker, because all of this is completely open source. So if you just wanted to build some sort of IoT fleet where you had a live mode and you wanted to some sample implementation of that, you could check out our firmware that walks you through exactly how to build that sort of thing. Same sort of thing with this web application. If you're just looking to build a really good dashboard for your data, or something that is like not only viewing data, but also being able to configure devices on the fly. Because this could also easily, this is a web app, but this could totally be like a mobile app. Person at the emergency could be bringing this up on their device, using that to configure things as well. So I think there's a lot of cool things in here to check out. Yeah, it's one of my favorites, indoor floor level tracker. Like Zach, I'm going to go hang out in the chat in the Q&A, and I'll pass the baton to whoever is next.
Awesome. Thanks, TJ. TJ makes a great point that a lot of these projects that we're showing you don't necessarily need to be exactly as we provide them. Like, they're meant to kind of inspire people and use them for very like similar use cases, so they don't have to be an exact implementation. So next, Tyler, I believe. Cool.
Yeah, I can go. Can you guys hear me okay?
Yes.
Let's see if this works. Can you see my screen?
Yes.
Okay, so on that note, on these app accelerators being to a T or not, what I'm going to show a demo of today is, I guess, not exactly as this app accelerator is, if you were to find it on hackster.io or GitHub. But this is essentially a CAN vehicle monitor. And taking a step back on what is CAN, we have a lot of wires and devices that need to talk to each other. Let's cut down on the wires. That's essentially where the need for CAN bus came from. And then there's different types of protocols, such as OBD2 for your vehicle. And that's what I'm going to be showing today. And what are some applications that you might want to log or sense CAN data? One thing that immediately comes to mind is kind of a black box of sorts. So it would be easy to take a note card and an SD card, or even no SD card, and to log data on my vehicle or my fleet. And if something were to happen, then I have a black box to go and see what the issue was. And along the lines of that, I have predictive maintenance from sensors and things of that nature. If you were to go to the GitHub, you would see this demo, which is essentially, this is emulating a vehicle, and this is more or less the same thing here. So if you turn the potentiometer here, it's changing the color of the LED here. Are you guys able to see this video okay? Did that?
Yep.
Yep. Yeah, it looks good.
Okay, thanks. So rather than just show this, two devices talking to each other, I have two of these Feather CAN MCUs, and it is driving this note card on a carrier F. And this device here is essentially, the emulating a vehicle port. And one key thing to keep in mind here is, like I mentioned, there's a need for CAN because you're trying to cut down on the wires, and then there's even more protocols that you can dive into more specifically for different needs. But CAN, in the example, there's all sorts of Adafruit, Feather, Huzzah, Arduino boards that will fit on our carrier boards. So I want to use CAN. I don't necessarily want to go through all the work of finding, a daughter board or an additional hat of sorts. I can just buy this on Amazon quickly, and it's got CAN bus integrated. I don't have to solder anything. I don't need to spin a board. I can buy everything and stay on the software side of things. So that was the next step. In this demo, you can kind of see that I'm transmitting, just basically emulating what the car is sending. And here is basically that same hardware. I've got a note card on a carrier F, and it is plugged into or off of this CAN port is OBD2. And I just glued something onto here because it was very difficult to unplug this from the OBD2 port. But it is more or less what you see here, where that OBD2 port is this driving force. And I got a couple of magnets on there, so I can slap it onto the side. And in the case of the car, I'm just showing torque, which is a Android application, but you can see there's all sorts of metrics that I can read just off a normal Bluetooth OBD2 reader. And Rob's use case with power loss detection, let's say I have my car and it's in storage, and I want to make sure that, you know, it's got the right temperature and humidity, and or I have a very expensive boat that I want to make sure the bilge pump is constantly running. I have a very easy solution for that, and I have the framework for doing a lot of things from a flexibility standpoint. Like I have CAN bus, I have a demo that does something rudimentary. I have the tools to expand on that. And here in this demo, oops. Oh, same one, sorry. So here I am showing, I guess this is my live demo since I'm down in the basement and don't have cellular. I recorded this last night, but I'm on Notehub here, and Notehub is extremely valuable. I don't think that I'm going to do a good job of vocalizing it, but if you're doing anything with cellular and high volume, it is a headache. And if you want to take any sort of sensor data and bring it to the cloud, we can help you with that, and it's very easy to do so. And Notehub helps you do that. So here I can update my firmware on the Notecard itself, or this Feather device, and I can do that over the air from Notehub. Here I'm seeing, if you were to follow along the GitHub example, you can see that we're transmitting that data here, which aligns with what we're seeing in our output. Okay, and one other takeaway that has been mentioned a couple of times is just how many different platforms are you can utilize. You name it, it's possible. We have documentation. And if you're curious where your data is going and how reliable it is, just go to status.notehub.io and you can have a better idea. Thanks.
Awesome. Thanks, Tyler. And last but not least, Hayden.
Yep. How's my audio?
Good.
Sounds good.
Cool. Sorry for the scary lighting, everybody. I'm in my bathroom. This is going to be a demo with another sink. Part of our rebrand. We're actually a sink company now. So let me share my screen.
Love the hat, Hayden.
Thanks. Representing the Los Angeles area. All right. So this is going to be our one demo that demonstrates a little bit of machine learning. So what I've done here is I've got a running faucet detector. And so it's a simple binary audio classifier, which is a type of machine learning model that can distinguish between two different classes of audio. In this case, it's the sound of a running faucet and just background noise and everything else. Detections are detected by the firmware and the machine learning model that's embedded on our Swan MCU, and then they get forwarded to Notehub and they can trigger alarms or whatever you want. You can imagine receiving a text message in this particular use case, as we've shown with some of the other apps. So on the left here is my little PDM microphone. So it receives the audio signal, converts it to PDM, and then via some wires over here, connects to my note carrier. And we have firmware and an open source audio library that we recently released that can convert that PDM signal to PCM. And so PCM is what you would expect in like a .wav file. So it's 16 kilohertz audio, 16-bit samples, super straightforward, uncompressed audio data. And you can also see the note card, of course, on there, along with the antenna. Power isn't connected here, but it will be for the demo. Let's see, there we go. So this was built with Edge Impulse, which is a company we work with a lot on these machine learning type applications. So they have a really great interface for training and deploying machine learning models that work at a level of abstraction that allows you to not, know how to design the individual layers of your neural network and to work at like a higher level, which certainly makes it makes this technology a whole lot more accessible for the average software engineer. So what I'm showing here is on the right, this is just a GIF of those PCM samples pouring out of the microphone into my serial monitor. And Edge Impulse actually allows you to just print to serial on your device and then forward those samples onto their cloud. And then from there, you can classify the samples, depending on what their labels should be. So, if I turn the faucet on and I'm collecting training data for that, I could then label that audio sample as faucet, and I can control how long I want to sample for, and it will automatically detect the frequency of the data as well. So I mentioned 16 kilohertz audio, and you can see that it got it just about right, which will be perfectly fine for this application. We also have what's called an Edge Impulse route. So we mentioned routing a couple times with Twilio. That's the text message service. We also allow you to collect data in the field without an internet connection and forward the data via cellular to Edge Impulse, where you can then label it for training. So if you're far afield and not close to Wi-Fi, you need to detect thunder in a forest for like a wildfire detection application or something like that. That could be interesting. It would be potentially a little bit difficult with such high data rate here. Just to get 1 second of audio is 16,000 samples, but accelerometer data, things that are lower bandwidth like that, are a great candidate for our Edge Impulse route. So then this is just to show you how you construct the model in Edge Impulse. Again, it's working at a pretty high level of abstraction. You have your time series data coming in, 1 second audio window. So grabbing little 1 second chunks and classifying whatever the model thinks the audio is within that window. Again, the frequency, this is like a feature extraction thing that converts the data into something that's more useful for a machine learning application. In this case, it's called MEL frequency. The classifier here is extremely abstracted, but for you machine learning nerds, it's like a 1D convolutional neural network. And then it will output the probability of each class, both faucet and noise. So for example, if I turn the faucet on, we'll see here in a second, it'll probably predict it with like 99% certainty that it's the faucet, not the noise. And then here it also gives you some stats on how much flash and peak RAM usage you'll see with this model, as well as the latency. And for these real-time applications, latency is pretty important. You don't want to miss audio samples. So the total time through the model is just a tiny 207 milliseconds, and that's on an embedded device. 27 kilobytes of flash and peak memory usage of about 20K, which will be perfectly fine on our Swan MCU. So we talked about environment variables a bunch. There's a couple of interest here. So I've configured these at the project level. Again, you could do this at the fleet level as we've discussed, but for the purposes of this demo, it's just for my project. The detection threshold is a parameter that basically above this probability level will produce a positive detection. So we want to be really certain in this case that the faucet's actually running. So we're only going to consider a positive detection anything above 90% probability, represented here as a value between 0 and 1. This is the label of interest. So you can imagine you've had like a classifier for 5 different classes and you're interested in just one of them. You would specify the label for that class here. And then the publish rate is just a sort of throttling mechanism such that we don't flood Notehub with tons of detections for the same event. So this is in terms of or in units of seconds. So at most, we will send a detection note to Notehub once every 60 seconds. This is what I'm about to show you, but I just wanted to include a GIF of it in case the video quality is not great. So what you're seeing here is I turn on the faucet, and then I turn on the LED in the firmware when a positive detection happens, so you can get some sort of immediate feedback that it's working. And then in the serial monitor, you'll also see, if you have it connected to USB, you'll see the persistent output of the classifier showing, it's just noise. And then all of a sudden the faucet turns on and it's predicting it with near certainty. And then it actually publishes a detection as well. And you'll see some environment variable updates sprinkled in there as well. So I believe that's the end of my slideshow. Let me stop sharing that. And if I can reposition my camera here without knocking everything over, you'll see the hardware setup I was talking about earlier. So this little mic is hanging down in here, and I won't get it wet with this faucet, but if I turn this on, see the red LED came on, and it'll stay on until I turn the faucet off. Great. I'll share my screen again, and we can go check out the detections on Notehub, and you can see what those look like. Let's exit this. Refresh the page here. You can see I'm in Los Angeles, so my local time is about 8:53, and that is the most recent detection. And you can see predicted faucet with like 99% certainty. That was really fast. Also, the latency to receive this detection, so that's great. And then, as we've shown before, you can also, this is the sort of application level JSON that gets embedded in here, but there's all sorts of other information that the Notecard adds by default that could be of interest, such as like a timestamp and Unix time, the particular request that added it, as well as GPS data if you have your GPS antenna hooked up. So yeah, that's the binary audio classifier. But with Edge Impulse and Blues, you could deploy all kinds of machine learning applications like this. We have one in the works right now for object detection. You could do image classification. But the bottom line here is, for these devices that are far afield, that are typically hard to get training data for to connect to the cloud, like we're one of the best solutions out there. So yeah, I think that's all I got.
Awesome. Thanks, Hayden.
Sure.
I know we only have a handful of minutes left. Let me share my screen again really quickly. Because Hayden's demo was perfect timing, because I want to let you know in July, at the end of July, we're actually hosting a TinyML plus IoT plus cloud bootcamp of sorts. So it's a hands-on but virtual workshop with physical hardware. You can get all the details at bit.ly/blues-tinyml. So we actually walk you through building your own machine learning based application, runs on a tiny microcontroller, just like Hayden showed you, also ties into IoT in the cloud. We ran one of these a couple months ago. It was great. We had tons of interest. So if you're curious about this, I suggest getting in sooner than later. Great for anybody who's like kind of a beginner or intermediate level with machine learning and the IoT. Finally, before we jump into Q&A, again, I know we only have a few minutes here, but I have a few resources to share. Again, head to blues.dev/accelerators for that giant list of all the Nifty 50/accelerator applications. And again, check out the TinyML bootcamp at bit.ly/blues-tinyml. Finally, if you're new to Blues, feel free to take 15% off your first starter kit at bit.ly/accelerate15. Just note that that discount doesn't appear until checkout. With that, let's switch over to answering some of your questions. And if you want to squeeze some in here, we have like literally 4 minutes. And I will, let's see, let's go through some of the questions here that have come in. TJ got a question about did you use sensor fusion or some ML technique in indoor floor in the indoor floor level tracker to get data? Is it firmware or web at the back end?
It's asking about like how it knows the floor has changed or there's no motion for the alarms. And right now the firmware is what's keeping tabs on that. And the current implementation just looks for no floor changing. That's its threshold it's using. You could, again, this is open source configurable. The Notecard also has a built-in accelerometer that you could use for that as well. You could hook up your own accelerometer. There's a lot of things you could do to determine what no motion or what the alarm situation is to you. But basically, I think the core of the question is what's handling that, and it's the firmware is managing that detection. Cool. And then when it detects it, pushes a note out to Notehub, and then Notehub can route it if it wants to, or conditionally route it, or whatever makes sense for whatever you're building.
Somebody also asked which couldn't figure out which protocol you use for the RF connection, if it's LoRa, Wi-Fi, Bluetooth. Just to be clear, everything that we showed today was cellular, either using like Cat1, or LTM, or NB-IoT. And question came in about, can I install Blues Notehub on a personal server not connected to the cloud? Yes, so we do have an open source version of Notehub. It's a very much a minimal implementation. It just receives data from a note card that is available on our GitHub account. If you choose to play around with it, we feel like the Notehub we offer at notehub.io provides a ton more value in terms of like fleet management and routing and environment variable management and all that. So, but you're welcome to use the open source one as well. And
also plug, as we're coming up on our time, if you're watching the video of this, or if you have questions later on, our forum at discuss.blues.io is a great place to go to ask any questions. All of us see the questions that you ask, and we do our best to try to jump in and help you out.
Another good question came in earlier about, do we have interoperability with other platforms like ChirpStack or TTN, the Things Network? It's a great question. So today, no, there's not like a turnkey integration with these LoRaWAN platforms. It's something we're definitely thinking a lot about, though, and yeah, should have more news in the future on that. I know that's a very hand-wavy, vague answer, but it's the best I can do today. Otherwise, I think we addressed most of these throughout the demo. So with that, we can end on time. Thanks, everybody, for attending. Again, like TJ said, head to discuss.blues.io for our forum. Otherwise, check out those accelerators at blues.dev. Thanks, everyone. Thanks, speakers.
Thanks, everybody.
Thank you.
Thank
Bye.
you.